All right, so we're going to talk a little bit about quadratic equations. What is a quadratic equation? Why do we care about them? That sort of thing. A quadratic equation is any equation which has a sort of squared term. It has x squared or t squared. It can be any variable, but some variable squared. And then it has some variable to the first power. And then finally it has some constant that's added in there that has no variable at all. In fact, the general equation, what we call the general form, looks like ax squared plus bx plus c. This is sometimes called descending order because look at your x term. It's x squared, so it's some number, some coefficient, but then it's x. A coefficient is what we say is in front of the variable. So it's some term squared times some term to the first power times some term to the 0 power, right? 2, 1, 0. That's what's called descending order. So sometimes you'll see it like that. So that's kind of what we have here, right? So we have x squared minus 4x minus 13 equals 0. In this case, a would be 1, b would be negative 4, and c would be negative 13. That's our constant there. But let's say we set this equal to 0 as you see here, and then I said, okay, well, what is the solution? When I say solution, I mean what values of x, what do I need x to be in order for this to work out, right? So this is kind of, you can see why this would be tough. Because traditionally, if I say solve for x, the way that you have done that is you've isolated the variable, right? You just get x by itself. But you're going to find that to be pretty much impossible in this because there's two x's. So you can get one of them by itself, no problem, and maybe you think you can sub it in or something, but it won't work, right? You cannot get x by itself here because there's two x's. So we have to come up with the creative ways to solve this. We have to come up with different ways to figure out the solution here. This isn't going to work if we just try to get x by itself. One of the ways is called factoring. I'm not going to go over factoring today because I think you'll go in other classes and really it won't be very useful for us because factoring almost never works on the physical problems that we're talking about. You could not solve this by factoring because factoring requires you to come up with something that multiplies together to give 13 and adds to give negative 4, and it's just not going to happen because 13 is a prime number. So you may say, well, is there any way we can solve this? And the answer is yes. There's something called, it's called complete the square. And it looks like this right here, right? If I had, let's say I had x plus a squared, right? X plus a squared, if I multiply that out, that just means x plus a times x plus a. You would use your FOIL, right? First, outer, inner, last. And you'll get, and you can try it out for yourself, but you'll get x squared plus 2ax plus a squared. Well, this is sort of a quadratic equation, right? It says x squared, x by itself, and then no x back here. This is our constant. But if I have a quadratic equation in this form, right, then I can rewrite it as this right here. And suddenly, there's only one x here. I mean, there's kind of two x's, right, because there's a square. But you can take the square root, and there'll just be one x by itself. So complete the square is where we want to write an equation like this and turn it into what we call a perfect square. So we can write it as x plus a. So the way that you can do that is really we just set it up exactly like this, right? We're going to say this is what I want. This is what I have. X squared minus 4x minus 13 equals 0. We want to move this 13 to the other side. So then I have x squared minus 4x equals, we add 13 to both sides, we get positive 13. So we can work with this because if this is x squared and we make this 2ax equal to 2ax, then all we have to do is add something to both sides. That's why it's called complete the square. So we're adding or completing what's here. All right, so if this is 2ax, right, let's set those equal to each other and figure out what a is in our substitution here. So we're saying 2ax is the same thing as negative 4x, right? We're saying these two equal. And then this is easy, because to get a by itself, I just divide by 2x on both sides. And a is negative 4 divided by 2 is negative 2. So back to this, right? I now know for this problem right here, a is going to be, right, for this equation, a is going to be negative 2. So what I have to do to complete the square, right? We already have x squared. We set that, defined that 2ax. we still have to add this a squared thing. So if a is negative 2, a squared is just, well, it's just negative 2 squared, which is positive 4. So I need to add 4 to both sides. Just regular 4, no x's or anything, just plus 4. So now I have x squared minus 4x plus 4 equals 13 plus 4 is 17. And the reason why we want to write that is because now if this is the same thing, right? If this right here is the same as this right here, then we can rewrite this as that, x plus a squared. So this can be rewritten as x plus, what was a? A was negative 2, so x plus negative 2. Or you could say x minus 2 squared. And now we can actually solve for x, because we just take the square root of both sides, square root, and we have x minus 2 equals. Now when you take the square root here, you actually, there are two possibilities, right? Two things can give you 17 when you square it. It could be negative 17 or positive 17, so we use this plus or minus. And then finally, we just add 2 to both sides. So we get x equals 2 plus or minus the square root of 17. I forgot my square roots on. So what you could do here is you can put that in your calculator. You can figure out what the square root of 17 is. It's not a perfect square, so it comes out to some decimal. Square root of 17 is 4.123. So you get, for your final answer, x equals, there are two options. Either 2 plus 4.123, or you could get 2 minus 4.123. They have two answers, right? And so you either get 6.123 or negative 2.123, and those are your answers. Now you could check that really easily. So either x is 6.123 or it's negative 2.123. You could check that quite easily. You could take this number, 6.123, put it back into this original equation for x and see if it works out. See if you get 0. If I do that real quick, I do 6.123 squared minus 4 times 6.123 minus 13. I put that in, I got 0.000871. So clearly there's some rounding stuff. That's one of our solutions. The other one also works. I'm not going to put it in right now to save time, but you could easily plug this second number back into x and you'll get 0. So these are answers. We call them roots when we talk about quadratic. These are the roots of the quadratic equation. These are the answers. You get 2 of them. And again, the way that we completed that was we used complete the square. We did complete the square here. Okay. I want to do one more problem with complete the square. I wrote this one down. All right. So you could have, let's say we had 2x squared plus 7x minus 4 equals 0. All right. Let's say we wanted to use complete the square here. So once again, a couple things we have to do. First of all, we don't want this 2 here. We want to get rid of the 2 in this term. So because we're multiplying by 2, what we could have to do instead is divide every term by 2 to rewrite. So I have x squared plus 7 over 2 times x minus 4 divided by 2 is just 2 equals 0. So we did that. We're also going to move this to the other side. So we have x squared plus 7 over 2 times x equals 2. So now we're going to complete the square. We have to figure out what a is going to be, though. So one more time, when I say complete the square, I mean we have to make it like this. X squared plus 2ax equals, or plus a squared. Because then that will be equal to just x plus a squared. So x squared, check. That's why we divided by 2, so now it looks like x squared. We're going to say these next two terms are equal so we can figure out what we have to add to both sides. That's what a is. So if I say these two terms are equal, I'm saying 2ax is the same as 7 over 2 times x. So again, to get a by itself, divide both sides by 2x, divide by 2x. X is canceled. 7 over 2 divided by the 2 is the same as 7 over 4. All right, so that's what a is. Then the last step I need to do is I need to add a squared to both sides. So a squared in this case would be 7 squared over 4 squared, 49 over 16. So now my new equation is x squared plus 7 over 2 times x plus 49 over 16 equals, on the other side, again, we have to complete the square, you have to add a squared to both sides, because if we do it to one side, we have to do it the other for the equal sign to remain true. Equals 2 plus 49 over 16. Again, it looks pretty ugly, but because we wrote this out correctly, remember, we said that if these two are the same, which is what we just did, we made these two things the same, then we can just rewrite it as x plus a squared. So this stuff, even though it's really ugly, turns into x, a is 7 over 4, plus 7 over 4 squared. And you could check that, right? You could do FOIL, and you should get the exact same answer back out. We don't have time to do it now, but you could easily do that, check and say, well, does that really work out? If you do x plus 7 over 4 and multiply by itself, you should get this thing back out here. On the other side, again, we can combine this. 2 over 16, or 2 is the same as, I believe it's 32 over 16. So then I have to do 49 plus 32. I don't feel like doing that in my head. I think it's 81. It is. So this just turns into 81 over 16. And now we can take the square root. Now we only have one x, so now we can just solve it like we regularly would. So take the square root to get x by itself. We have x plus 7 over 4 equals, remember, plus or minus. You just take the square root of top and bottom. 81, take the square root of 81 is 9. That's kind of nice. Over the square root of 16 is 4. So then, get x by itself, we just subtract 7 over 4 on both sides. And our final answer is, it's just fractions. X is, there are two options because there's always going to be two. It's going to be negative 7 over 4 plus or minus 9 over 4. And that's an answer. Again, that's two numbers. You can turn this into fractions. Obviously, divided by 4, you get like 0.25. It actually works out pretty nice. So our options are negative 7 plus 9 is 2 over 4, which that would just be 2. Or negative 7 minus 9 is negative 16. Is that right? Two over 4 is not 2. 2 over 4 is 1/2, by the way. That was wrong. Or negative 16 divided by 4 is negative 4. So again, those should be answers. And you could go back and check. I'm not going to do it now. I don't want to take too much time on it. But you could take 1/2, put it back in for x, and see if you get 0. And you should get very close. In fact, actually, because we didn't round, it should be exactly. Same thing with the other one. You take -4, plug it in, you should get 0. Okay, so for this next part, here's what I want you to do. I don't want you to take any notes. Don't take any notes. For some of you, it's not an issue. But don't take any notes. Just watch and keep up with me, okay? Because what I'm going to show you is, I don't know, it's like the mathematical equivalent of eating your vegetables. Or it's a mathematical equivalent of doing up-downs or doing crunches. It's something you don't want to do, right? But when you do it, you become more empowered if you do it, okay? So what I'm going to show you, it will get really, really nasty for a minute. But then at the end, I think we'll get this nice little revelation that will be beneficial, I think. So let's say you didn't want to do quadratic. Let's say you think, you know what? This complete the square thing, it's hard. I don't like doing it. It's like a lot of stuff, a lot of algebra. I don't want to do it. So you make this compromise. You say, okay, what I'm going to do is I'm going to set up a general equation for a quadratic equation. And I'm going to do complete the square with that right there. And if I can do complete the square with that right there, then what I'll end up with is something I can use in every single problem from here on forever. So it's going to be gross, but we're going to do it one time, and then we'll have a tool that will help us in all our future quadratic endeavors here. So let's do that. Just like every other problem I've done, I'm going to do two things first. First, I'm going to make sure this coefficient is 1, right? So now notice the coefficient here is a. So I'm going to divide every single term by a. Divided by a, divided by a, divided by a. Even divided by a. Of course, 0 divided by a is not going to matter. So I'm rewriting my equation, and I'm also just going to go ahead and move this to the other. Well, I'll do that separately. Okay, so now it says x squared plus b over a times x plus c over a equals 0. Next thing I'm going to do, I'm going to move this to the other side, this constant to the other side, because we want to complete the square, which means we're only going to look at these first two terms. So I'm going to minus c over a on both sides. Minus c over a. Minus c over a. Oh, okay, so it goes away. So now my new equation that I've simplified for my x is x squared plus b over a times x equals negative c over a. Okay, here's where it's going to get a little messy, but again, I just want you to follow me as best you can to see where we're going. One more time, if I can write this as x squared plus 2ax plus a squared, then I can write it as just x plus a squared. That's the goal. So I need to figure out if I'm saying this, okay, x squared, check, the first terms, check out, that works out. So I'm going to say that 2ax, right, I'm saying this term right here, 2ax, is going to be equal to this term right here, b over a x. I know they're a's and stuff, but they are different a's, just to be clear. All right, so I'm saying those two equal. I would like to know, because I'm going to have to add this a squared, I need to know what is a equal to. So to get a by itself, all I need to do is divide by 2x on both sides. So this is easy. Right here, the 2 over 2, x over x, it cancels. So we have a by itself, which is what we wanted. So a is going to be equal to. I don't want to take too long on the math here. You can write this out as a fraction, and then you multiply by the reciprocal of this fraction. So you would do b over a x times 1 over 2x. But when you work it out, the x's will cancel, and this 2 will be in the bottom. And so a is going to be b divided by 2a. What's a squared? Because now we got to add a squared to both sides. So if that's a squared is simple. Just square the top and square the bottom. So a squared would be b squared over 2a times 2a is 4a squared. Okay, so back to our complete the square, I'm just going to add that to both sides, that kind of ugly term. I'm going to add a squared, add b squared over 4a squared to both sides. So now it looks like this. X squared plus b over a times x plus, there's my new term, b squared over 4a squared equals, okay, remember we have to add this to both sides. So I'm going to change the order a little bit, but it doesn't matter because I'm just adding. So this is going to be b squared over 4a squared minus c over a. Now, because we did all this nasty stuff here, we can rewrite this and make it look a lot nicer. Maybe not really nice, but a lot nicer. Because remember, if this is all this, then we just can, it's equal to x plus a squared. So this whole side here is equal to, what's x plus a? It would be x plus a is b over 2a squared equals. Let's simplify this other side a little bit. Notice how we have a squared and well, we have 4a squared and a. Let's make these like terms, this common denominator, I guess is what you would say. Let's give this a common denominator. So to make this a common denominator, we don't have to do anything to this. 4a squared is going to stay the same. But to make this bottom also 4a squared and not change it, we have to multiply top and bottom by 4 and by a. So this first term does not change. It's just b squared minus, I'm going to rearrange, right? Instead of saying C4a, I'm just going to say 4ac. Doesn't matter about the order there because I'm just multiplying. And this is over on the bottom. The new denominator is 4a squared. All right. Now, if this is a square, I'm just going to take the square root of both sides. Square root of both sides. Square root of both sides. So this is the square root of x plus b over 2a squared is just x plus b over 2a. On the other side, remember we got to do that plus or minus thing. Square root. The top doesn't change very well. It's just b squared minus 4ac over, if we do the square root of 4a squared, right, so off to the side, the square root of 4a squared is just 2a. 2a. And then, very last thing, to get x by itself, we subtract this b over 2a. So minus b over 2a minus b over 2a. Well, hey, that's kind of nice. They have the same denominator. That worked out really well. So then all I'm left with, x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Of course, we can combine these because they're like terms. And I've also run out of space. So, I can go over here. So then we get, for our final answer here, what is x? As simple as we can write it is x is, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Which you may know as a quadratic formula. And the point of me showing you all this is that the quadratic formula is not something that we found on a rock and we said, or we found in a book and we said, wow, this thing happens to work, let's use it. It's something that we made, we created, we discovered, I guess, by simply doing complete the square. If you take a general form, a quadratic equation in the general form, and you do complete the square, right? It's a lot of algebra. But if you do all the algebra, eat all of your broccoli, so to speak, then at the end, what we end up with is this tool right here. And this makes all of them easy. This makes every quadratic equation from here on easy. Because if I have some weird quadratic equation like, I'll give you one that you're going to see, or a very similar one you're going to see. What if I had y equals negative 4.9 t squared plus 13t plus 18, right? That would be really tough. Imagine doing complete the square with that. It would get really nasty. But now I just know I can plug this into the quadratic formula, right? And I have negative 13 plus or minus square root of 13 squared minus 4 times negative 4.9 times 18, right? So we can take those coefficients, and it's going to be ugly still, but our calculator can do that. We can use a calculator to figure this out. So the quadratic formula is quite powerful. It allows us to solve quadratic equations very quickly by simply picking out those coefficients. But again, the quadratic formula is not something that was just given to us. It's not something that we don't know where it came from or why it works. We know why it works. It's just complete the square. So quadratic formula and complete the square are the same thing. It's just the work has already been, the algebra has already been done for you. You've already done all the algebra. And so you get this formula here that's very nice that you can use for any quadratic equation, and it works for any one. Right? So again, I expect you to probably answer questions using this right here, right? Using this quadratic formula, because we should be using it. We worked hard to get it. We should use this tool. But what I wanted you to see is that this doesn't come from nowhere, right? This comes from somewhere. And I should mention the first people to solve the quadratic formula like this, to derive the quadratic formula, I mean, they were talking about people 300, 400 years ago. So again, I know sometimes I think we have a bias where we think like people today, we think we're really smart. But again, there's always been very smart people throughout history. And again, we're doing this kind of because we're following patterns other people have established. But there are some people who, did this on their own, which is pretty amazing. So anyways, that's where the quadratic formula comes from. It is the same thing as complete the square. So you don't really need to use complete the square because it's already been done for you in the quadratic formula. And so that combination should let you solve any quadratic equation. You can always use complete the square if you want. You can always use, you can use factoring on a few, but because we're always going to have like negative 4.9 t squared, that pretty much throws factoring out the window. Factoring is just not going to work for any of the quadratic equations because there's not many nice factors of 4.9. Right.